Okay, that first exam deals with a lot of fractions, so that's where I'm gonna start. We'll just focus on simplifying fractions and the operations: addition, subtraction, multiplication, division. Okay, but first we gotta simplify. So if you're asked to simplify, write 78 over 80 in lowest terms. I'll call this example 1. So if you have a fraction, if you ever want to reduce a fraction, you just want to divide it by the biggest number you can. And sometimes if you're not sure, you can start with a smaller number and then repeat. I know that 2 goes into both of these because they're even. And if I take half of 78, I get 39. Half of 80, I get 40. And at that point, we can see this doesn't reduce any further. If I gave you something like, let's say 30 over 36, the biggest number that goes into both of those is 6. So if you divide them each by 6, you'll have your reduced fraction. However, if you don't see that and you just said, well, they're both even, you get 15 over 18. And you say, well, wait a minute, there's a number that goes into those. That'd be 3, right? So you can take them down by 3 and then get your final answer that way. Okay, so anytime you're working with any fractions like we are for the rest of these problems, you're going to want to reduce your answer like that if you can. All right, let's look at an addition problem. For adding fractions, you need a common denominator. Okay, so you need a number that both of these go into evenly. So it has to be at least as big as the bigger one. Right? And in this case, 16 does go into 32. So 32 will be your LCD. Right? I don't change the first fraction, but I realize if I multiply 16 by 2, I can multiply 3 by 2. I'm sorry, 16 by 2 to get the LCD 32, and then I just have to do the same to the top and bottom. So 3 over 16 is equivalent to 6 over 32. We just unsimplified the fraction, and now we can add them together. The rule is, when you're adding fractions, get the LCD, write your answer over the LCD, and then add your 2 numerators. And then at that point, you want to reduce it if you can, but for this example, it's not going to reduce, so 7 over 32 is your final answer. So number 3, we're going to do the same thing, only we got these mixed numbers, they're called, right? An integer with a fraction. So in order to deal with these, we always multiply denominator by the whole number and then add. So you go 4 times 2, that's 8, plus 1 is 9. So 9/4 is the same as 2 1/4. And then the same thing here, 4 times 5 plus 1, 21 over 5. Okay, and now we're on to the same step as the second question, but 4 doesn't go into 5, right? So in this case, the LCD doesn't show up like it did here. It was given, but we have to figure out what it is. So what I do is I start, if you can't figure it out, I start with the bigger of the 2 denominators and start listing its multiples. 1 times 5, 2 times 5, 3 times 5, right? And from this list, we know 5 is going to go into this list as I keep going. And you're just asking yourself, when does 4 go into one of these numbers? And the next one I get to, 20, should work. All right, that's going to be my LCD. And once I realize that, then I have to say, okay, how do I get from 4 to 20? I multiply by 5. So I do the top and the bottom. How do I get from 5 to 20? I multiply by 4. And that'll give me my new unsimplified fraction. So 9 times 5 is 45. 4 times 21 is 84. And then, same rule as we did up here, you leave the LCD and you add your 2 numerators. 929 over 20. Okay, so the computer should accept that answer when you do these on your exam. You could also write this as, so here's another part to this chapter. You have to write this as a mixed number sometimes. So you can ask yourself, how many times does 20 go into 129. We'll go in 6 times, because 6 times 20 is 120. And that would leave you with a remainder of 9. So an equivalent answer. These two are the same thing. Okay, typically in math, we like the improper fraction, but sometimes you'll have to work with these mixed numbers. But most of the time, it's going from a mixed number to an improper fraction. We like those a little bit better. They're a little bit easier to work with. Okay, so that's simplifying fraction. A couple examples of adding. Let's do some multiplication. Of always means multiply. So I'm going to go 2/5 times 5, 6. Okay, now when you multiply, basically what you do is you just multiply the two top guys and you multiply the two bottom guys. You do not need an LCD. Multiplying is actually easier than adding. It's less work. So when I do this, I would get 10 over 30. But there's an easier way. If you have like factors in the top and bottom, you can simplify them, just like we did with reducing the fraction in this first example. I can do that here. I can say, well, 5 goes into 5 once, into 5 once. I can do the same with 2. 2 over 6 reduces. What can you divide them both by? Divide them both by 2. 2 divided by 2 is 1. 6 divided by 2 is 3. And then what do? You multiply the tops 1 and get your answer. Okay. The other way to do that is if you didn't recognize that simplification, you can actually just do the multiplication and not simplify first. 2 times 5 is 10. 5 times 6 is 30. And then reduce this fraction like we did before. I recognize that 10 goes into both of these numbers. So I divide them both by 10, and I get the same answer either way. I like this way better. I don't ever have to deal with a 10 and a 30, those big numbers. I can reduce it kind of before I get to the answer. Okay, so that is simplifying. We did 2 addition. Now, if you do a subtraction, I'll call this 4. It works the same way as addition. Let's say I ask you to subtract 5, 6 minus 1/4. So you need an LCD, and you get the LCD, and then you do the subtraction you do the operation in the integers like we did with addition. So if I'm having trouble finding the LCD, 4 doesn't go into 6, I start listing my multiples of 6. 6, and then 12. And I realize right away that 4 will go into 12. So that's the LCD for what I'm calling example 5. So I go 12 and 12. And I say to myself, how do I get from 4 to 12? I multiply by 3. How do I get from 6 to 12? I multiply by 2. And I end up with my new equation, 10/12 minus 3/12. And just like addition, we do the operation in the numerator. 10 minus 3 is 7 over 12. Okay, so that's my answer. I try and reduce that, but 7's prime, so nothing will go into 7 and 12, so I'm done. Okay, one more. We haven't done division yet, so that's the last one. So this one's in the form of a word problem. How many sheets, 5 3/4, can be cut from stock 24 and 7/8? So you're dividing 24 and 7/8 by 5 3/4. Right, you're dividing up. How many of these sheets can you get out of this? You're going to cut it up into 5 3/4. So how many times can you do that? So let's do the division. But before we do division, we have to change this to an improper fraction. So 24 times 8 is 192 plus 7. So again, we do this times this, and then we add the 7. So it's 192 plus 7, so that's 199 over 8. That's the same as this guy. And we do 4 times 5 is 20, plus 3 is 23. Now, here's a new rule for you. Whenever I divide by a fraction, it's the same as multiplying by the reciprocal. So I leave the first guy as is, and I flip the second one around and change it to multiplication. And then I do that thing where I try and reduce if I can. So 4 goes into 4 once, into 8 2 times. And then I go ahead and I multiply 199, and I get 2 times 23, 46. I'm going to help use my calculator here. And now I got to take this back to a mixed number. So I go 199 divided by 46. It would be 4 times. It goes in 4 times. So 46 times 4, 24, carry the 2, 16 plus 2 is 18. Right? So that would leave me with a remainder of 15. Okay, so you got to be careful with this word problem. Now, this is the answer. This is what 24 and 7/8 divided by 5 and 3/4 is equal to. However, you can only get 4 full sheets. That's the question. How many full sheets? Because this is not a complete sheet. So the answer to something like this, you have to do a little bit more work than just the math, would be 4 full sheets.